Hello, welcome to the SpecSizer video on the case for reduced voltage starters. When working with SpecSizer, we may complete a sizing and find an oversized genset suggested as the best fit for the actual running load. This is visible on the capacity column of the Select Generator Set page. We can see here that for this example, we have a C27 as the suggested generator set, and we can see that it's using only 26.2% of its capacity. This situation is not good. It means that the engine will struggle to reach proper operating temperature, which can lead to wet stacking condition, as you can see on the note on the top of the page. This is going to have a negative impact on the engine life. A sizing like this is often a result of motor starting requirements that far exceeded the running load. Let's take a look on the loads added for this sizing example. More particular, the three-phase engine load. You can see here in the bottom of the load page the inrush of 1940 skVA. Comparing it to the running load of about 218 kVA, we can see that there's a great difference between them. On this example, we can see that the starting method selected is direct online. If we were now to consider reduced voltage starter, for example, Y delta starter, we are going to see a significantly lower impact in regards to that inrush. The difference between them will be reduced. As we can see now, the inrush is reduced to 646.7 skVA, which is not as far from the running load as before. We can save our changes and go back to Select Generator Set tab. By using the Y delta starter, we can see now that the recommended generator set is a C9. The package was reduced from a C27 engine to a C9 engine. If we look at the capacity now, it's using 78.5%. That means we have now a generator set with a running load that matches its capabilities. This concludes this training video on the case for reduced voltage starter. Thanks for watching, and please send us your feedback to help improve your experience with SpecSizer.